Hello everyone and welcome back to Programming Chess with me. I know that's a really good title, isn't it? So, last time we were just looking at how different programming languages work, how they're converted so that the computer can understand it. I would recommend checking it out, even though it's not compulsory, seeing as we didn't actually work on the program last time, because I just wanted to get that out of the way to explain more stuff and why I'm doing things that I'm doing. So, going back about 6 weeks ago now, wow, it's been some time, we finished working on how a bishop and a rook move. And I asked if you guys would like to help out, well, not help out, but you know what I mean, in how the queen should work, because we have the rook, we have the bishop movement. A queen just uses both of those and combines them to move. The easiest way, I believe, which makes sense in my head, is just to do if this or that. And then it's a valid move. Meaning, if we take what we have here, so this is the rook here, this is my bishop, and this is my queen. I want to copy this over to my queen. Make sure that's indented correctly. So that's the movement from the bishop. Then we just go to the end. What I'm doing here is just using my home and end buttons, if you didn't know that already. It makes it much easier to move from one end of your code to the other. So that's the bishop movement. Then we get the rook movement by just getting the if statement, or whatever is after the if. And we're saying either bishop movement or this movement. I'm putting them in parentheses just in case, so that it's more easily understandable which one's which. And I believe that that's the queen's method done. So let's just look at a chessboard, for example, here. Oh, I did not mean to zoom out. So I am also going to use this professional chessboard I made last time over here. Let's put a Q there. So how we made our bishop method work is by checking whether a number and another number are evenly divisible to get us a value of 1. Or no, if the change in the x and the y is when you divide the change in the x by the change in the y, if you get 1 or minus 1, is when it's a valid move. And for the rook, we made it so that if one changes but the other one doesn't. So if x changes but y doesn't, or if y changes but x doesn't. So let's check if that works for the queen. Because we're saying if either one or the other is correct, then that means that it should be correct. So if the queen moves up, then we're saying that 3 stays the same, which means x stays the same, y changes, which is an acceptable move. Down, same thing, left and right, same thing. If we try to move the queen like a knight might, so say to 2-1, then it's going to check, has the y changed? Yes, it has. Has the x changed? Yes, it has. Okay. Let's try the bishop movement, because that's not valid for the rook movement. Is the change in y divided by the change in x evenly divisible by, well, does it give us a result of 1 or minus 1? So we have change in y is going to be minus 2, change in x is going to be minus 1. Well, that gives us a value of 2. Minus 2 divided by minus 1 is 2. Therefore, that's an invalid move. So using that logic, I believe that the movement for the queen should easily work based on the bishop and the rook movement. Okay, so now that we have the queen working along with the rook and the bishop, why don't we get the king working, seeing as they kind of move similarly, because the king can move all around himself, like the queen can, but the king cannot move any further, and it should be quite easy to do. So the king can only move one spot. Therefore, what we want to check is that the maximum amount of change in x or change in y is 1, and it can change in both. So we just want to write that down. Seeing as this is pseudocode, it's not that difficult. Let me just see how I'm doing it. Okay, so if change in y, okay, I'm just going to write it as change in y and change in x. Change in y, should probably capitalize it differently just so that change in y equals 1. Then, so if change in y or change in x is 1, or change in x is 1, then return, and that's supposed to be all capitals actually. I haven't done it as all capitals previously. Return true. I might go through and change that later on. So if that, or both of them are true, then we can make a move. Otherwise, else, we can return false. Because if they've moved any more or any less, I just try to stay in the same place, then that's not a valid move. And therefore they should return false and be asked to make another move. So that's the king done. Now let's move on to the pawn. So the pawn has 3 special conditions that I can think of. So you have the special condition where there's a piece which you can attack. There's en passant, and then there's at the start where you can move you can make 2 moves at once. For now, we're just focusing on the normal move, which is just moving 1 square forward. Therefore, what I want to do is just check whether the change in y is 1. And that's all we want to do. If it is 1, then it's a valid move. If it isn't, then it's not a valid move. Which means what we do if change in y equals 1, then we want to return false, else return, and I did this wrong, so this should be returned true. As you can see, I also changed the capitalization of all of the returns, because in pseudocode you should normally do all of the commands in all capitals. And also I would recommend doing the booleans in capitals as well, or 1s and 0s. That's also acceptable. Although, if you want it to be a boolean, it's sometimes more obvious if you do it true and false. So that's the pawn done under normal conditions as well now. Also notice that for the pawn, because we're saying change in y, that means it can be either moving up or down. So depending on which player is making the move, we might want to specify which way we want to move. However, because this is pseudocode, I'm not going to go into that much of detail. However, I am going to get into the special conditions once we are done with the normal conditions. So, next thing to think about is the knight. Or horse, I don't exactly... No, I'm pretty sure it's called the knight. I'm just going to stick with that. So how the knight moves is... Well, let's get my primitive movement here as well. Knight marked with an N, normally, because the king is marked with a K. So the knight can move, you have 2 moves up or down, and then 1 to the left or to the right is where they can move. So the knight can move there, 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 and there, as well as there and there. Or represented on a chessboard, say the knight was on d4, they can move to e6, f5, they can move to e3, f3, no, e2, sorry, f3, c2, b3, b5, and c6. So they can move to 8 places on the board. And they can jump over any pieces, so that's something we might want to consider or not consider, depending on the case which we want to make it work, because other pieces do depend on their path being blocked. however this one doesn't. Therefore we might not want to include a function which sees whether there are pieces in the way for the horse to get to the spot in which they want to. Horse, knight, you might hear me say both, sorry about that. So the horse can move. Let's think about this. So what I've come up with is similarly to the bishop, we're gonna want to use some maths to solve it. So I think the best thing to do is to make it so that if change in y divided by change in x, or change in x divided by change in y is equal to 2. So if change in y divided by change in x equals 2, and if it's a change, then it's an absolute value, meaning it's always going to be positive, so we don't need to check that. Or we have change in x divided by change in y is equal to 2. If either condition is met, then we should be fine. I'm going to explain my logic in just a second. Let's do that, and then we do return, oops, that's not what I had in on my clipboard. Return true, else return false. There we go. So if the knight is there, he has to move to there. That's 2 in y, a change of 2 in y, and a change of 1 in x. So 2 divided by 1 is 2. If we check the other condition, 1 divided by 2 is a half. Okay, that's not correct. However, because we have an OR condition, if this is met, then this doesn't have to be met, therefore this should be correct. 2 divided by 1 is going to be correct. Let's look at this spot, for example, again. Removing 2 in y, removing 1 in x. 2 divided by 1, again, is 2. Therefore the condition is met. Let's see an incorrect spot. So there, change in y is 1, change in x is 1. 1 divided by 1, well, that's 1. So neither condition is met, therefore what we should get is false. Let's look at this spot, which again is correct. We have a change in x of 2. We're going negative 2, but because it's an absolute value as being a change, we have 2. Change in y is 1, so 2 divided by 1 again is 2. Let's look at an outside spot, so let's look at that. Change in y is 3. Change in x again is 3. 3 divided by 3, well, that's 1. Now there is a problem if you look at something like the knight being here. If the knight is here and they try to move it to not there, but they try to move it to there, then we have a change in y of 4 and a change in x of 2. 4 divided by 2, well, that's 2 again. However, we can think about that later on. We can also consider making sure that the change in y and change in x are less than 4, always less than 4. So we can also check that. Let's just find where our knight is, over here. So we have that. If that's true, and change in y is less than 4, and change in x is also less than 4. In which case we're never going to get that condition. Because if they're moving 3, well, we can even make it 3 here. Let's just look at this. So if they're here and they try to move 3 up, well, that they can't exactly make a move in any of that row. Or if they want to move 3 to the left, 1, 2, 3, they can't make a move in that whole column. Therefore, what we can do is even make that smaller, so we can check if it's less than 3, meaning it's 2 or 1. We can even check if change in y is 1 or 2. However, that would be slightly more difficult. Well, not difficult, but it would require more coding. And because we can just do this, it's much easier. So that's the knight done under normal conditions as well. So the next thing we should be thinking about is, the next special condition is when you're in check. All of the pieces behave much differently when you're in check, as you have to protect your king. However, we do still have the pawn to work on, which is over here. I don't think that any of the other pieces have any the king also has the special condition of when you're trying to castle, i.e. if there's an open space between your king and your rook. So if the knight and the bishop are out of the way, what you can do is move the castle to here, and then the king jumps over the castle. That's a special condition for the king. And the other special condition is for the pawn, the 3 special conditions I mentioned previously. And I guess the rook and the king together along with the pawn. So the next thing I am going to think about, I think, is the pawn. First of all, let's think about the beginning of the game where you can move a pawn 2 squares forward. The best solution I could come up with was, well, count how many moves the pawn has made so far. And this would be for each pawn. We will have to instantiate 4 pawns, and we can count for each separate pawn. Therefore, let's find our pawn. Here we go. We can add a class variable called moves made, and at first we can set it to be equal to 0 because, well, the pawn hasn't made any moves. Now, in our method for check valid move, we can also say if change in y is 1, but also, or moves made equals 0, then we can make it so that they can move the pawn 2 spaces forward or backwards. So we're going to ask for the change in y to be 2. So what we do is just put moves made equals 0 and change in y equals 2. So if both of these conditions are met, so if either this condition is met or this condition is met, then return true, allowing the piece to move. So this condition will always be allowed. You will always be allowed to move the pawn 1 square forward or 1 square backwards if you're the black player, from the white player's perspective, but that doesn't matter for now, as I said. Or if you're trying to move it 2 squares forward, in which case we want to make sure that you haven't made any moves. And if this is true, then we want to also increment moves made by 1 before we return anything, because otherwise we've just exited the method. Moves made plus equals 1. And we can do that after each move because, well, why not just count how many moves we've made anyway? Not that it really matters. We could make this a boolean, have moved, that might save on efficiency. However, there's nothing stopping us from doing it this way, because I also want to do a similar thing for the rook and the king for the special condition of castling. However, I'm going to get onto that later on. I just want to finish the pawn first. So the next thing, so that's one of the 3 special conditions. The next special condition is when you have a piece to the right or left which you can attack. So what we want to check is, well, why don't we just imagine a method called is there a piece to left or vertical left or diagonal left or diagonal right, which returns true or false depending on whether there is a piece. Just imagine that that exists. We can perhaps add that here just as check. So diagonal, or no, we don't need it even there, we can just put it in the pawn. So diagonal enemy, why not? And it returns true or false, so that would be boolean, and it returns true if there is, returns false if there isn't. We can check both of the squares. So I'm looking at this pawn, so it checks both of these squares. Is there an enemy? If there is, then we want to make it a valid move. Or, so I'm going to put parentheses around all of these different conditions. So this, or the special condition of diagonal enemy. So if that returns true, we don't have to say equals true, because if it does return true, then it is true. If diagonal enemy on the square that we're looking at, we don't have to specify that because this is pseudocode. And no, that's all we need to check. So, or diagonal enemy, the square is specified. If there is a diagonal enemy on that square, then you are allowed to make the move. Meaning, so if you give the game an input of e3, and on e3 there's, say for an example, a queen for some odd reason, you're giving it the square, you're giving it the coordinates. Diagonal enemy returns true. Because we have an or here, if this is true, we don't have to check any of the other conditions. So this is going to return true, allowing the pawn to move to e3. And that is all done. We could ask diagonal enemy to return as the coordinates if we really wanted to, but I plan on doing it in a different way so that the coordinates are given to the piece straight away. So we use those coordinates each time we want to move a piece. Therefore, this should be acceptable for now. And the next and last special condition for the pawn that we have to consider is en passant. So what that is basically, let's say the black player has just moved the d7 pawn to d5. And the white player somehow has their e2 pawn on the e5, what the white player can now do is move their e5 pawn to d6, even though the black pawn is on d5, because that's en passant, and you can read up on that. It's spelled, let me just spell it here. I really hope I spelled this correctly. En passant. I think it's spelled like that. I can even search it up just to make sure that it is. Yeah. Anna. No. It's en passant. Like, it's spelled like that. But yeah, you can look into that. I'm not going into the details of why or how. I'm just programming a game that does how chess works. So I'm not worried about that. So let's check that as a valid move in here as well. Or what we want to do. So this is going to be quite a difficult one, I believe. We want to see diagonal enemy won't work here because, well, there is no enemy there. However, what we can do is check whether there's a pawn behind the diagonals of our pawn. If there is, then we can check whether that pawn has only just moved and only made one move. So we can compare the positions of pieces in the previous state of the board to the current state of the board. What I mean by that is, say this is so a starting board is the previous state of the board, and the current state of the board is the e3 pawn, no, the e2 pawn is on e4. We can keep both of those in memory. We can keep them both and then compare whether in the previous state the e2 pawn was on e2 or was on e3. If it was on e2 and if it was on e3, then the black player cannot do en passant. However, if it was on e2 and is now on e4, then the black player can do en passant. So that logic, we can just write it out in pseudocode for now and not really think about it too much, and later on we can actually program it, because we haven't exactly thought about how the board works. So I'm just going to leave it slightly ambiguous in pseudocode because it's pseudocode, we don't have to think about it too much, but I have explained my logic of how I would do it. So check, I would do something like, I'm just going to paraphrase it, I'm not even going to do a proper programming thing. So check the previous state of the board, and if pawn has been moved twice, well, 2 spots forwards. I'm just going to state it as that. It should be quite obvious of what I mean, and I have explained it as well. Again, if you have any questions, do feel free to ask in the comments. I will be happy to explain what I am thinking and how I'm thinking it. So I think that that's going to be it for today's lesson. I know I might have run over the 15-20 minute time limit I have set for myself, but I think that that was worth it. In the next lesson, I plan on firstly finishing off the special conditions for the king and the rook, and then thinking about the special condition of check, or checking for checkmate even. And I can't think of any other special conditions, but if I find any, then that's going to be in the video as well. So until then, thank you so much for watching, and goodbye.